Okay, so ladies and gentlemen, here we're going to do a couple of extra examples from our classwork today. And of course, this is coming out of our McGraw-Hill workbook and some of the questions that they have in here. So it's going to be 2-2 angle relationships. And we did a couple of these in class to begin with, but let's just look here at number 2. Because number 2 and number 3 are set up very similar. And it says, angle E and angle F are complementary. We know that complementary means that those two together will add up to be 90. And then it says the measure of angle E is 54 more than the measure of angle F. And then find the measures of each angle. Okay, so what we're looking at here is, to begin with, so we're looking at, there's my equations that I could look at. I can say angle E plus angle F is equal to 90, and then angle E is equal to angle F plus 54, because it says it's 54 more than. Now, I can't necessarily just work straight here with this as a system, but what we learn in solving these equations is that we can do some substitution. And since I know here that angle E is equal to this amount, well, I can turn around and replace angle E with that amount. And then that way, what I've done is I've gotten to where I only have one variable to solve for. So I'm going to go ahead and substitute in this value for angle E, since they're telling me that that's what angle E is equal to. So in my first equation, I end up having angle F plus 54 is equal to, plus another angle F, right, equals 90. Now I can go ahead and combine like terms, and I have one angle F plus another angle F is I have 2 times angle F plus 54 is equal to 90. Subtract 54 from both sides using my inverse operations to isolate my unknown angle F. So I have 2 times angle F is equal to 90 minus 54 is going to be 36. If I divide both sides by 2, so I can isolate angle F, my unknown, and then angle F is going to be equal to 18 degrees. And that's a really good start to solving number 2. And if I'm able to find angle F, well, I can go ahead and plug that value back into my original equation right here. So I know that angle E plus angle F, which we now know is 18, equals 90, and therefore subtract 18 from both sides, and we find out that, angle E is therefore equal to 72 degrees. So there we go. Those are my answers. I got angle E is going to be 72 degrees and angle F is going to be 18 degrees. And that's how I could work that problem. Now, I would tell you, looking at this, it does seem to read that number 3 is set up very similar, right? You have 2 angles that are complementary, and then one angle is 24 more than the other angle. So you should be able to use this, this method to do this problem. We set up number 4 in class, so I'm not going to go over that. And then if we look here at number 5, looking at just the equations that I'm going to work with, it reads M and N are complementary. So again, 90 degrees, okay? So angle M plus angle N are equal to 90 degrees. And it tells me also here the measure of angle M, so I have the measure of angle M is 38 degrees less than the measure of N. So that would be the measure of N minus 38 degrees. There we go. So we are now in that same kind of substitution that we did in this example right here. We can do that with number 5. And then it looks like, again, this number 6 is set up the exact same way. Q plus R are complementary, so they are equal to 90 degrees. And then the measure of Q is going to be 26 less than the measure of R. So it looks like these two are very similar in format. So if we had created this equation, we should be able to create the other equation. Let me see, and I did number 7 in class on the board, setting that formula up. Let's see here, or setting up the equation, sorry. Number 8, find the measures of two supplementary angles if the difference between those measures of the two angles is 62. We did several examples like this in class, but I mean, let's just look here. Number 8, I know that we're dealing with two supplementary angles. So I have angle 1 plus angle 2, those are my two angles, are equal to 180 degrees. And then it tells me that their difference, so angle 1 minus angle 2 is going to be 62. And there you go, there's that system that we can work with, and we can end up combining down to find our solutions. So we have examples like that in our classroom. All right, so now I'm going to go ahead and some of these are going to be the same thing as you move down here. I'm going to go ahead and move on to this next example of example number 2. And let's see, we'll say here, reading, rays BA and BC are perpendicular. Point D lies on the interior of ABC, and if ABD is 3R plus 5 degrees, and the measure of DBC is 5R minus 27 degrees, find ABD and DBC. Sounds like a lot of, ABCs, yeah, you know me. But let's see, if I'm looking at rays, I have ray, okay, BA, and I have ray BC. All right, got those two, and they're perpendicular. And then it tells me that point D lies interior. Point D, and then it tells me that, let's see here, I'm going to come up with some angles. ABC, measure of ABD. So here's my angle, ABD. That measurement is going to be 3R plus 5 degrees. And then DBC, right here, DBC is going to be 5R minus 27 degrees. And then it wants me to find these measurements. Well, if you look, these two angles, this angle plus this angle, add up to equal 90 degrees, so they're complementary. So I would start that equation. I would say, okay, well, I got angle ABD plus angle DBC equal 90 degrees. And now I can substitute in these values to create my equation and keep going. So there you go. That's how we can work with these, and these are some ways to illustrate what we're doing to where we can fill the equation in and keep going. If we look on the back, let's see, I can probably find a couple more here to do real quick. How about number 17? It says AB and CD intersect at point E. Okay, not a very pretty line. Okay, so I got AB, they intersect at E, and then CD, and then if AED, okay, so AED, that is over here, AED is 6x minus 24 degrees, and then CEB over here is 4y plus 32 degrees. Find the values of x and y such that AB is perpendicular to BC. If they're perpendicular means they're 90 degrees, So if that's the case, in order to find those values, we would say 4y plus 32 is equal to 90 degrees. Because they're telling me that it's 90, they're telling me this is what it's equal to. There you go, that's that substitution. Over here, I'd do the same thing. I would take 6x minus 24 and make that equal to 90 degrees because that angle is equal to 90 degrees. And that's what they're asking for here in number 17, not 71, number 17. Okay. That is the best way to illustrate that information. Now, if I skip down to example number 3 down here, right here, these are a little bit different. There's a lot of answers that can happen here, but it says, determine whether each statement can be assumed given the figure. I want to know if 6 and 8 are complementary. Okay, so in order to say they were complementary, they would have to be 90 degrees. And I can tell you that we actually know that. That is a true statement. When I look at this, remember that this forms a straight line right here, and a straight line is a straight angle, which is 180 degrees. Well, if angle 7 is 90 degrees, that means these two angles together, 6 and 7, should be 90 degrees because together they make 180 degrees. So that's a true statement. Okay. Now 7 and 8, right? We have this angle and then this angle right here. It says form a linear pair, and that's not true because these two angles do not form a straight line because we have this angle number 6, is not accounted for in angle 7 and 8, so they do not form remember, a linear pair are adjacent angles, and those two angles are not adjacent, forming a straight line. 2 and 4 are vertical angles. Let's see here, 2 and 4. They are definitely opposite angles through the vertex, so they are two lines intersected. Those guys are opposite, which, yeah, they're vertical angles. That is a true statement. And let's see what is last here. Measure of angle 9 is equal to the measure of 6 plus 8. I believe that's going to be an accurate statement too, because we learn here that the measure of angle 9 is 90 degrees. And then the measure of angle 6 plus 8 is also 90 degrees. So yeah, that is absolutely a true statement. Absolutely a true statement, and absolutely a true statement. This is no bueno. Does not work. So hopefully being able to walk through some of these examples to get you guys started will help you building the other equations. So again, we'll discuss more of this in class, but you know, we've got a jumping off point now. Again, this is 2-2, our angle relationships from our classwork and our textbook.